Oh, he's pretty good. Oh, yes. Okay. Have you see this? So that's, I know that homework is still open, but that's okay. This answer sheet will eventually also be available on the syllabus, but now it's locked until the homework is closed. But now let's take a look because very, very similar question. It will be on exam. Very, very similar. Okay, I'm giving you guys the short answer is literally going to be the same objective. Okay, so I'm not going to go through every single question, but I'm going to go through this exercise this way. Let's look at this table. Keep on forgetting that this is not touch screen laptop over here, but let's look at this table. First question, is this table normalized? Is it in second normalized form? Is it in first normalized form? Is it in first normalized form? Okay, someone tell me why is it not in first normalized form? Wait. Raise your hand. Just say one. One each.
There's grouping.
Lark, can you say it louder, everybody?
There's grouping user follow.
User follower, there's multiple values. There's groups, data structure type of values in there. Yes. Number one. What else? User follower over here. Look at this. It's trying to store multiple followers. User, like. Okay? Yes, that's a violation of first normal form. Anything else? Yes. To last second. Yeah. Okay. So yes. Trying to also store trying to store duplicate names, or again, similarly trying to store multiple values, right? Because it could be another last check-in location 3, 4, 5, whatever, right? And then you see the redundancy immediately. Yes, the second problem. What else? What else can you see? Maybe there isn't anymore. Let me double check. Yeah, I think that's might be it. Okay. All right. Those are the two I can see as well. Now let me ask: are these being null a problem for 1NF? Is that violations of 1F? What first normal form? No values, empty values. Is that a violation? Just so we confirm that you understand it. It's not. Okay, I don't care. I mean, first normal form does not specify null or empty string as a violation. Okay, duplicate names, duplicate columns, data structure or group or groupings or multiple value type, mixed domains. Now, there's no example here that shows mixed domains like I can see. Mixed domain is another problem. No value is not, empty string is not, empty cell is not. Okay, so that's first problem. Now, what we'll need to do quickly is now we're seeing this, and let's say essentially the question will be from this table, how do we normalize this so that we can make it into second normalized form, right? Basically, that one of the questions on this homework there is, right? So first of all, we can immediately see, right, is there's definitely one actor or entity here that is users, right? It looks like there is users, definitely, right? In here. Because if you think about it, right, the second normalized form, they cannot have partial dependency. So if there is any non-key attributes it needs to go to its own table with their own primary keys, right? So you can see that over here, you can identify that there is user email that follows user ID, username following user ID. So that should in itself is definitely an entity. Now, profile URL is probably following that, right? But now this location, there's multiple locations that gives away that there's definitely going to be its own as well, right? Because you can see this location is not relevant to user. It has nothing to do with user, right? Furthermore, you see that there is also some type of relationship here that is follows, right? A user follow another user, right? So we see like there's at least a couple of them that we can work on, right? Now, what about account? What about account? The social media account type or this account? Any very strong opinions on what we should do with the accounts?
I think we can include them on the users
Mhm,
table.
mhm.
This is what I think.
So on the first site, I would say that the account so far doesn't have any issues to having to be with users. Yes.
I was gonna say like we get a separate table and then. You could have a user ID as the foreign key, and in the table you could have the account type, handle, and profile URL, and that would just. Social media account table.
Yeah, so there's so immediate for account. This part is actually in here, but there's up to your interpretations. So there's multiple ways that you can handle this without violating 2NF for the account ones. One of them, because this account handle and the URL, it is unique itself that follow just like user, it will follow user, but it could also be a one-to-one relationship on its own, right? And you can take out the social media type because this media type is definitely technically it could be reused, right? For example, photograph, public figure, it could be reused, meaning like another user could be also a photographer, right? It technically can also be in a table by itself with the ID, right? The type, it technically be. So this part of an account for the homework is actually open for interpretation. So both you are right, both you are right for now, okay? Without violating 2NF. But the immediate violation of 2NF, I can see, well, first of all, immediate violation of 2NF is it's already not in 1NF. So it's definitely immediately not 2NF. But the second part is after you identify the first NF, the couple of things that you could do also, I mean, this is following normalization, but you could really see that there's user and definitely location, right? And then there's this multiple value in here that tells you that there's a many-to-many relationship that is definitely needs to be out, right? All right. So for the first question, here is to draw it into an F. Okay, and then I gave you guys like a kind of like a example, which is on your homework, but now this is one of the answer type. It's not very clear, is it? Let's see, is there a way for me to make it more clear? Are you guys able to see? I don't know how to make it more clear. Because it's within a browser and Google Doc, it's not the slide. Can you guys kind of see? All right. Okay, so over here, it's kind of like, what's your name?
Me?
Yeah.
Oh.
So what you mentioned is similar, you're mentioning is having the account type with an account together, right? That is one of the options. Or you have the account with the user, that's also one of the options, because for now, that's not validating, that's what your have, is having account and users together. Now, if you really want to have it separated, you could have user, but it will be a one-to-one relationship, because you can see that every user in the table, followed by an account, those accounts are also unique. You have not seen a user having multiple accounts, at least in the original table, right? That's fine. But the account type is very likely to be reduced. So account type, right? So maybe one account could be reused by multiple account, right? So that's why that possibly you can have that. So this part is open for interpretation. It's not going to really, the exam is not going to have this type of vague ones, but just so you know, as an exercise. Now, the important part comes here. Okay, so there's check-ins, right? The check-in field that was storing essentially is locations. And those locations were city and country, basically, right? Remember that? And there's multiple of them, right? So location, right? Location over here with the landmark. And then the country ID, because country can be reused. Right? This is a one-to-many relationship over here. For example, there's like I think Berlin Wall on there, and then there's some type of Brandenburg on there, right? So they're both from Germany. Germany is reused, right? So country by itself should be a one-to-many relationship from location to country, right? Now, the part that there is check-in, there's multiple value in there. In order to separate and then to make it to an F, right? It's a many-to-many relationship, right? A person can check into many places. A place can be checked in by multiple people. It's a many-to-many relationship, right? Can multiple people travel to Berlin Wall? Yes. Can I go to Berlin Wall and then I go to, I don't know, like Checkpoint Charlie in Germany? Yes. I can go to multiple places, right? So it's many-to-many relationship. So what you do here is user, right? And the location is a many-to-many, but for 2NF, you have it, a transit table. In here, you can name it check-in or you can say user underscore location. It's fine, but for here, I think check-in is valid because it was already on the original table anyways. Okay, so you store that with the two foreign keys. One is the location foreign keys, the other is the user ID over here. Then you have the timestamp. Location ID. It's actually missing a user ID in the check-in. So this actually is the user ID over here. It's actually not just the check-in ID. I don't know why it's missing one, but anyways, you have one over here, one over here. So two foreign keys, one from local location, one from users. Okay, so that's number one, where the many-to-many, the first many-to-many situation. And second part, many-to-many situation, as we see in the original table, is storing the followers, right? So followers are also users, right? So user follows another user, or a user is followed by another user, right? So that means user and user itself has a many-to-many relationships. And that relationship will use a transit table to quarantine it. And we can name it following or follows relationship, right? Therefore, here is the transit table of following. But uniquely, it both come from user. Right? Because the person who followed and the person who's following are both users. Okay? So remember, when you do two one-to-many relationship because they're child table. You actually need to draw twice. Don't. You may not notice this, but like this is very important here. If you have this table that both come from the same place, don't just have one-to-many relationship cardinality. You need to draw both out to indicate that the follower and the followee are both users. Okay, now those are the two transit tables that we are going to use to solve for the many-to-many relationship because we need to draw it in the 2NF. Now, let's have the final check here. User and location. Before we have a check-in table, these two, essentially they have a many-to-many relationship, right? And we know a many-to-many relationship will not stand within the 2NF normalization. So we use a transit table, right? And now we're breaking it. So now it's always one-to-many, one-to-many. Without looking at one-to-many, one-to-many, let's use that shortcut that we just reviewed earlier, the recital that we used earlier. Now, this check-in table is the child table, right? Because it has the foreign key, which means that it's inheriting the DNA, which is the primary key from the parent table, right? So, location is the parent table. Check-in is the child table. So, always one parent, multiple child. One, many. The 0 and then another extra bar here, those are optional. You don't have to draw that. That's like, do you guys remember what that was? You only require to draw, like there's two lines here. There's two lines here, and then there's two also simple here. Do you guys remember why there's two? The other one is the optional cardinality for minimum. Meaning like, can this be null? Or can it has to be has one, right? Or can this check-in be null? So can a location never been checked before? Yes. But this thing, the 0 and then the extra bar here, those you can omit that. You're not required to draw that, but you need to draw the fundamental relationship, which is the one-to-many. Okay, fundamental. If you optionally want to indicate the minimum, that's fine. Okay, similarly, user and check-in. Okay, so check-in here will have a user ID, which is the foreign key of the referencing primary key from user, right? That means user is the parent table, check-in is the child table. Therefore, the many sign is always at the child table. Again, so I draw the many probably here. Okay? Yes.
Actually, you said accounts user was one-to-one.
Account and user. Yes, this is one-to-one. Yeah.
But user have multiple accounts. When I did, I said it's many to one.
Yeah, I mean that. Well, okay. Remember, I said this specific user to account is up to your interpretation from the table that's given. This is sufficient. But I get, for example, what they said previously. There's different options for this specific. But your idea, thinking one person can create multiple, like business account or personal account, that's fine. Like I would say, okay for it. But it's not like, basically yours is almost upgrade, like more advanced. That covers even more scenario, but this will survive. But yours is correct as well. Okay? Okay. Final reviews again using this. Okay. User and so the follower and followees. They're both user, right? So follower and followees has many-to-many relationship, correct? User can follow multiple people. A person can be followed by multiple users, right? So because of that, we break it out with a transit table and have, rather than many-to-many, we have two lines of one-to-many, right? And again, the transit table, which is the following following table over here, has the foreign key. That means it's a child table. Being a child table, the many 12-foot is always going to be there. Right? The 1 is always at the parent side. Okay? Now, the objective of your exam on this short answer one is going to be like the same objective, very same objective. It would be slightly less up to interpretation. It will be more definite. So this part of the count, that's for your homework assignment, like more like real life scenario, but your exam is going to omit as many vague possibilities as possible. There's really just going to be one answer. But you need to make sure that you have table names, okay? And you need to make sure you have primary key indicated, foreign key indicated, and last but not least, one-to-many relationship, one-to-one relationship, whatever, indicated at the right place. Okay. Also the data type. The data type part, it's not going to. I'm going to make it as easy as possible for you guys. Yeah.
Could you have location be a part of the check-in table?
The location be a part of what?
The check-in table, like as an attribute, and you just store like how you store an address, you just store the city and the country in the check-in table. Because each check-in corresponds to one
You can't though. Well, that wouldn't work because location would be checking by many people, right?
But doesn't check-in have the user ID as the foreign key? So then like one check-in.
I know, but then, okay. What I'm saying is that if you think about it, right? If you have this in here, then let's say if I have 3 people checking to Berlin Wall, that Berlin Wall is going to show up in the column multiple times. Right? Do you understand what I'm saying?
Yeah.
Yeah, so that's going to be valid partial dependency. Because you will have the same the check-in item. User check-in ID, location, user. One check-in, 2 check. Yeah, you will have check-in, and then you have check-in ID, and you have a user ID, right? And then the check-in ID and user ID. Let's see. Your user ID will have the user information still correct. That follows the user ID, which is your foreign key. But the location changes. So there comes a partial dependency that you still have to take it out. Okay? So if you put check-in, the obvious thing to look at, if you put location within location and the country itself all at once and then put it in the check-in, the problem is very easy to tell is that you're going to see multiple repetitive rows that has the same location. And I will say that immediately, even though hard to identify partial dependency immediately, like I will have to think just now too, but it would just immediately red flag that the same long data has to be stored multiple times. That's a waste of memory, right? That's probably a flag for you to think that's probably not right. You understand what I'm saying?
Yeah.
So, yeah. So you can't, this specific ones, no, you can't have the location in the check-in. The check-in and location should be, the check-in should be the transit table between user and location. Any questions? Did I finish saying what the requirement? Data type, table name, cardinality, lines, second normal form, primary keys, foreign keys. Okay? All right. There will be some answer over here. Also, I am storing, if you're, just in case you're curious. So previously I mentioned that you can use DrawSQL. There's another tool called Mermaid, and then it's using these more like pseudocode to create graphs. So if you're interested of how this graph translate into a pseudocode is this. So it's going to be posted online. It's going to post it on syllabus tomorrow. Okay. Now, let's see which ones we can talk about. The last question thing, we can have a quick overview. Okay, so based on your data model, based on your second normal form, based on your data model, query and retrieve the username and total follower counts for user who have no check-ins. The results should be ordered by names in ascending order and by follower account in descending order. A follower account in descending order. Okay, so run a SQL query to retrieve username and total follower, so that we know that definitely in select statement there's usernames in there, right? And total follower will probably be an aggregation, right? So we at least know that there's two properties that we need to put in select statement. From the user table, who has no check-ins? User who has no check-ins. Okay, so user left join following on user ID equal to following. And that left join will make sure that all the user is show up, and then it will show that also ones that it will left join to show your left join followings on user equal to no check-ins. Wait, hold on. User have no check-ins. User should be worried about this. User should have no check-ins. For the followings. Okay, so for user have no followers of user not no check-in. So user who have no check-in, I did it by filtering where clause. So it says user ID not in select user ID from check-in where user ID is not known. Okay, so in the check-in here, in the check-in table, I am choosing that all the user that shows up in the check-in table, I don't want to pick from the user table. Meaning that anybody who appear in the user table at least once, a check-in table at least once, has a check-in, right? If anybody who has check-ins to any location, because here I want no check-ins. User with no check-ins, right? So basically in the where clause, what I did is u.user ID. U is the table from users, right? So basically what I'm saying is I want the user who does not exist in the check-in table on the where clause. Take a second. Does that make sense? Because I want user have no check-ins. But I want to count the followers, but with user who have no check-ins. So I said user ID not appear ever from the check-in table. Okay, so that take care of the user who never checked in. Now I want to know the following. Okay, so whether or not I did left join or right join in this case, it doesn't really matter because user can have no followers at all, and then eventually in here I just want eventually know the one that has followed. So I do left join, right join. Essentially, doesn't really matter if as long as I don't filter it out. So over here at the bottom, I said group by. Group by user ID, as we know, and username. Now the user ID and username username needs to be matched on. Username needs to be matched on select that we know. The following counts is the aggregation. So this shouldn't be here. So username is now balanced on select query, not the count. The count because it's aggregation, so it can be there by itself. Finally, order by username, ascending order, and follow count, which we use as the alien here in the that we name in the count aggregation here. So I want to order by username first, ascending order, then I want to see the following count in ascending order. Okay? All right. So what I wrote here again, where false will filter out the user who never, this is using a subquery, as you can see here, in, and then another brackets that has a select statement. That's a subquery that we went over last week or before your presentation. And not in is just showing anything but whatever result in the subquery, right? So all the user that never shows up in checking table before. Okay? And user joining the following so that I can get all the followings that user have. Then eventually what I need to do is using count to aggregate the total amount of followers. And I have to group by the name because I want to make sure the count is divided by the person that they're following. Okay? And then I do the final part, which is the order by. Remember, I have here two ways, two requirements. First, ordered by name, then ordered by the count. All right, any question? So these two are the only one that I'm gonna go over, but they will be posted on by Wednesday. Will be posted on this list. The answers. Okay. If not, I am going to let's go over and look at exam review. Now, when you got next week, as we know, it's spring break, so you don't have any class. The week after is not exam yet. The week after, we actually have class. It's going to be topic that is not going to be covered on the exam, but it's the topic that we have to go over for the semester anyways. Right? I think let me just double check. No class next week. Yeah, the next sessions will be on Zoom after spring break. It's going to be lecture again. Okay. So, and it will be on Zoom. And then the week after that, we will have no lecture. It will be study week for you guys to study for the exam. So you essentially still have about close to a month until our exam, including the spring break. So about 77 days. Okay. And then on April 27th is going to be your exam day, which is before final week. So you should have no conflict. So just during the class, you just bring your own laptop, okay, and a piece and a pen. I'll provide the paper that you need to draw a diagram on. And then make sure that you're going to make sure that your laptop is ready for lockdown browser for the exam. Now, your next homework, which is due on the 15th, I believe. Actually, I added a section for you to, now I created a mock test on your Brightspace. So you can just go, if you can finish that mock test, which is just yes or no, like a multiple choice, it's not going to count or anything. But basically, if you can finish that exam, you should be fine. You just got everything you needed to download for your exam. Okay, I created one so that you guys can test before the exam. Okay, any questions on the format, first of all, and then the dates? Nothing changes. Now, so essentially, as I mentioned multiple times, today will mark all the coverage. Okay, no more than after today. no more after today will be included in an exam, okay? I haven't finished deciding what will be an exam, but the way it will work is that I have a lot of questions from a question pool. So, for example, it will be multiple choice there'll be about, I'll say, in your exam, there will be about maybe like, I want to say roughly 40 questions in total. And I want to say about, maybe less, maybe 35 questions in total. And I want to say like 25 questions are multiple choice. Okay, and then some of them will be fill in the blank, and some of them will be like short answer. So majority will be multiple choice. Now, my thing is the multiple choice will be, each person will be getting different different questions, because I have a question pool that has 50 questions, for example, and then it's going to pick randomly 40 for everybody. And then the weight of difficulty will be balanced. Okay, and the order will also be different. So everybody's basically will get completely different exam. Okay, so that's kind of how the format will work. What will be covered again will be up to today. Mostly, I would say that it's everything I speak about, and in your lecture notes, right? That's posted online. If you miss classes before or you're late, I would say if you can get notes from your teammate, will be the best way to make sure you're covered. Or else you just have to double cross from the lecture note, the slide, and the textbook. You understand what I'm saying? Like, if there's something that I speak about that wasn't, or you're not clear about, or like you're not completely sure like the detail, then I would suggest if you're missing class that day, get it from your teammates, or just cross-referencing on your textbook. Because essentially my lecture is extracting just executive briefing from the textbook itself, so you don't read that much, but basically what it is. Now, what will be covered? Why are these slides so blurry? Okay. It will cover from, the very beginning of the class, more fundamentally, how the data was stored back in the day, file storage, to database inventions, use cases of databases, and maybe a very high level comparison between NoSQL and databases. Okay? Now, someone asked me, even though it's not going to be really on an exam, but someone asked me like, how is database stored? I spoke about it before, but I don't think I'm going to add like database is really stored. But if you really want to know, relational database are stored in disks, like, cylinder disk that's spinning, kind of like server, right? I don't know if this is really important, but someone asked. But they have almost like playing like DJ when you're playing like that, like a disk spinner. There's some like pointer, and then the server itself keep on spinning the disk, and then all the data, every information is actually imprinted in the disk. It's almost like a CD player, but with like gigantic disk and in the server and running very, very fast. And all of the data in table is stored on there. And the data structure is actually stored on there that makes searching a lot faster. It's being stored in B trees. Does anybody know what B tree is? I mean, you can go and look at the data structure class, balance tree, whatever. Okay. And I remember I also told you that all these are just added information. But remember I told you that not only is stored in B tree that makes it faster than file storage, because file storage, how is it stored? sequential, right? So the log of n, the big O is always, for file storage, is always O with n, right? But B tree will always be what? Log n, right? All of log n. Or best scenario is 1, right? But in average is all of log n. This doesn't really, still, this is just good to know. But specifically, your indexes, how are they? Why is it faster? Fundamentally, is because it's stored in B tree, and each B tree is storing a page of your server. And that page server, that page of your server, of your that page of your B tree will store a table's rows and data in there. And if you added an index to your column, it essentially will list that index on the same page. And therefore, there's a faster search if you have an index on the column. Okay? Anyways, this is just if you're curious about it, okay? Now, I'm not going to go all the way into all that, but you should know still the difference between the different type of database. Yeah, so over here. And then okay, so you will need to know, obviously, for your short answer, you'll need to know how to get from either how we did Netflix with a functional requirement. How do you plan a database design to 2NF? Either that way, or from that table that we saw earlier from the exercise. There might be two options, like there might be two versions of how you're drawing your 2NF data modeling diagram. One is by early on that example that we did in the homework. The other one is when we did that first exercise using Netflix as an example, right? Those two ways. And you should also know about the integrity and constraints. The integrity and constraint, you just need to know the concept. I don't necessarily think that there's anything that you need. Oh, you need to know how to write query to create primary keys and foreign keys. Other than that, you just need to know the concept. You need to know what different keys are and what index does. Okay, and you need to know relationship type, one to many, many to many, one to one. Okay, and where is the foreign keys, where is the primary keys? As far as and you need to, as far as SQLs wise, as far as I think, if you remember that there is one session that specifically said that all these other are dictionary. Those were those ones that are like more like dictionary that you can look up W3 school. Those are definitely not going to be on the exam. But you need to know, and then I would say that the hackering, anything that is difficult level, like hard, are not going to be on the exam. The one that could be on the exam will only up to like medium. Most of them will be easy. The exam itself, I don't want you to really recite that much, memorize that much, but like basically, if you're writing a create table or when you're writing a simple select statement, it shouldn't error out. Just think of it that way. So, you know, primary keys, how do you create primary keys? How do you create foreign keys? What are the aggregation functions? Like these are very important ones. You just need to remember these basic ones, like keywords and basic ones, I would say. Let me see, anything else? Yeah, transaction, store procedure, triggers. These things are all going to be covered in the exam. You just need to know the concept. Okay. What else do you want? And here it's finally just what they are. Any question? The format or topic or materials that you want me to clarify? Or about the course so far? Or anything that you, or if you have any questions, specific questions that you want clarity for exam materials or topics that's going to be covered in exam that you want to just solidify your understanding, come to me after class. But for now, any questions on the exams or schedule? If not, just remember there's the homework still due tomorrow or today, tonight, tomorrow. And there's another one on 15, right? Which is after spring break, but it's, it's already posted. Any other questions for the remaining of semester? Okay, you're free to go, and I will see you online in 2 weeks. And if you have any question, you can ask now, or else see you in 2 weeks.